Okay. We'll discuss, don't worry. So the thing is that the concept of velocity of object and velocity of image, how to apply that concept, we will discuss first today. So last class we have covered some rotation and deviation of that mirror, means ray, how ray getting deviated, and if you rotate the mirror theta, that means angular velocity of reflected ray is twice the angular velocity of the mirror. Okay, so first topic today we will discuss about that plane mirror is there. There is a plane mirror. There is a plane mirror. There is a plane mirror. And let us say that there is a object. So if the object moves and if the mirror also moves, then how to calculate the velocity of the image? And also sometime in the question they ask the velocity of image with respect to object. So we will try to calculate two things. One is velocity, actual velocity of image, and second is velocity of image with respect to object. Right? Two things. So let us say that this object is moving in this direction. Okay, this direction. This, let us call this is velocity of object. Okay, actual velocity of object. And mirror also may be moving, so let us keep that mirror at rest. Okay, mirror may be moving, so mirror may be moving, mirror may also have some velocity, we do not know. This is velocity of mirror, and these are in vectors, it can be in any directions. Okay, so the first thing you have to do is, so they will give you the velocity of mirror, they will give you the velocity of object, right? Two things they will give. Now the first thing which we need to do is, we need to calculate the velocity of what? Velocity of object with respect to mirror we need to calculate. That means here the observer is on the mirror. So this is the mirror, or the observer is on mirror. We need to calculate what? We need to calculate velocity of object with respect to mirror. Okay, this is what we need to calculate. And then with respect to this, once you calculate, it will have two components. One component will be perpendicular to the mirror, right, and another will be parallel to the mirror. Let us call that this as x and y component, and assume that mirror is along the y axis. Mirror is along the y axis. So perpendicular to y-axis means x-axis. So this is the velocity of the object with respect to mirror along x direction. I will write bracket along x. And this is the velocity of object with respect to mirror in bracket y, means along y-axis, right? These two components you will calculate. And once you calculate these two components, what you need to do is, you don't have to do anything about this y component, because if the object is moving parallel to the mirror, the image will also move with the same velocity. Okay, because if the object moves parallel to the mirror, the image also will move parallel to the mirror. Together they will move, or down or up, like that. Okay, but what will change is, if the object is moving towards the mirror, image will also move towards the mirror, right? Or if the object goes away from mirror, image will also go away from mirror, right? So what will change is this component of velocity only calculation you have to do. Okay, so suppose if you consider that this is the image, this is the image, this is the eye image, and its velocity, relative velocity we are talking about. Relative velocity will be exactly in the same manner. Suppose it is making angle, some angle theta with the mirror, so it will also make some angle theta with the mirror. Relative velocity. Okay. So relative velocity of object with respect to mirror makes angle theta with the mirror. So this velocity also makes angle theta with the mirror. So now let us also resolve this. This also, when we resolve, it will have two components. Okay. So these components, if you take velocity of image, this is what? This is velocity of image with respect to mirror. Okay. So this component, when we are taking, this is velocity of image with respect to mirror, but this is again x component. Similarly, this is velocity of image with respect to mirror, but this is y component. Okay. So what is we need to note is that this y component velocity of image with respect to mirror, the y component is exactly same as velocity of object with respect to mirror, the y component. There is no doubt in this. This remains always same. Okay. But what changes is the x component only, which is perpendicular to the mirror. So that means velocity of image with respect to mirror, the x component is going to be minus of velocity of object with respect to mirror, the x component. So in x component, the formula becomes like this. There is a minus sign comes in this formula. That is what we need to note. Yeah, we will take one example. Questions we will take. Huh? So first let me give one question, and if you have any question on this, you can then give the question. Okay. So let me give a question on this. Suppose there is a plane mirror. This plane mirror is going. Now they are not showing which direction it is, but what they are given that this is moving in this direction. Okay, this velocity is given. Let us say its velocity of the mirror velocity is 2 I cap plus 3 j cap. This is the mirror image. Assume that this mirror is along the x-axis, or mirror is a plane, right? They may give you that this plane is xz plane. Sorry, yz plane. This is yz plane. Yz. This is y, and this is a yz plane. Okay. So the perpendicular to yz plane is only x direction. That's what we know, right? This is yz plane, means this plane. So perpendicular to yz plane is x-axis. This is x-axis. Okay, x-axis is perpendicular to yz plane. Then now what they have given is that there is an object, somewhere object is there. This object is going with some velocity like this. Let us say the velocity of object is minus 4 I cap plus 3 j cap, or uh, plus 7 j cap, like this they have given. Okay, they have given this. They will definitely give you that which plane it is. The plane of mirror they must give. So this is yz plane, and mirror is moving with some velocity, and object is also moving with some velocity. Okay, right. So what we need to do is we need to calculate, find the velocity of image and velocity of image with respect to object, with respect to object. That's what it is. Okay, they have given this. So first what can we do is we can think of, you can try to see the fastest way. If you want to solve in the fastest method, you try to resolve the velocities component. Okay, try to resolve velocity component. So we know that x-axis is axis which is perpendicular to the mirror. Okay, perpendicular. So first of all, you find out which axis is perpendicular to the mirror. That means find out the direction of normal. Normal direction. See, some easy questions are there. In easy question, they will give the normal is along x-axis, or normal is along y-axis, or normal is along z-axis. They may not give, but it is easy to find. For example, here the plane mirror is along yz plane. So perpendicular to yz plane is x-axis. Very easily you can figure out. That means if the velocity will change, velocity only along x-axis will change. That's all. Okay, that's all will change. Okay. So now first of all, let us try to calculate the relative velocity. Relative velocity we want to calculate. Okay. So what we can do is we can resolve the velocities first. Let us resolve this velocity into two components. This will have two component of velocity. You know already, you can see this is 2 meter per second, and this is 3 meter per second. These are the components, right? So the mirror is moving along x-axis with 2 meter per second and along y-axis with 3 meter per second. And if you see this object also has two component of velocity. In this direction is negative, -4 means it is going in negative x-axis. So I can write as 4 meter per second in negative, and it is going up with this 7 meter per second. Okay, clear? This diagram is clear. Okay. Now what we need to think is only in this direction velocity will change. The formula which we have to do the calculation only in this direction. Okay. So if I draw the image, let us say if I draw the image somewhere here, some image I draw. This is image. So note that this vertical component of velocity is not going to affect. So whatever is 7, it will remain 7 only. 7 meter per second it will remain. Okay, image. Now, what will happen is that relative velocity you are calculating first. Okay, so try to calculate the relative velocity along x-axis. So tell me, this is going away with 4 meter per second and this is going with 2 meter per second away. So tell me, when two bodies moves in opposite direction, what is the relative speed? Suppose two bodies goes in the same direction, what is relative speed? First, you should have this concept of relative motion. Relative motion means if two bodies go in the same direction, then you need to subtract the speeds. And if two bodies go in opposite direction, you need to add the speed. Yeah, this is what concept is. Okay, so here see these two bodies are going in opposite direction. Correct? Correct? Is going out. So relative to mirror, it is going away with 4 plus 2 6 meter per second relative velocity in this direction. 4 plus 2. Okay, this is relative velocity which is 6. So what is 6 here? 6 is the velocity of object with respect to mirror along x direction, along normal direction. Correct? Okay. So if you see the image also must be same, but its relative velocity is in this direction. Note that this is the velocity of object, it is in this direction. So the velocity of the image must also be in this direction because it has to be opposite, right? If it's going this way, it has to go this way. Okay. So that must also be 6. So what is 6 here? This must be velocity of image with respect to mirror along x-axis. Clear? But this is plus 6. Note that this is plus 6 and this is minus 6 basically. Correct? This is in opposite direction. So it is minus 6 it is. Clear? Okay. Now you got it. Now what is the, if I have to calculate velocity, first let me calculate velocity of image first. Image velocity, let me, if you want to write relative velocity, see let us write relative velocity here. I will draw first relative velocity vector. Okay, this is relative velocity vector. So velocity of, so relative velocity also have two components. So this will be the velocity of object with respect to mirror along x-axis, and this will be the velocity of object with respect to mirror along y-axis. Okay. Similarly here also. Yes. Yeah. What is the velocity of object with respect to mirror along x-axis? Let us write. So it is velocity of object minus velocity of mirror. Correct? Velocity of object minus velocity, and we are only taking along x-axis. So just first take x-axis component. X-axis component to take. So velocity of object along x-axis is what? -4, right? This is -4. So first write this as -4 minus mirror along x-axis is what? +2 it is. So that is +2. So how much this comes? That's what is -6. Correct? -6. Yes. Similarly, you calculate this one. Let us do this calculation. Velocity of object along y-axis with respect to mirror is velocity of object minus velocity of mirror, but you are taking along the y component. Okay. So do this calculation. Object along y-axis is 7 minus a mirror along y-axis is 3, right? So that will become 4, right? So this relative velocity here, this is 4, right? This velocity is 4, this is 4, and this is coming minus 6, correct? Right. So this is relative velocity. Now again, let me draw relative velocity diagram here also. I will draw relative velocity. So this I am drawing relative velocity. Okay, velocity of image with respect to mirror, and this is velocity of image along x-axis, along y-axis. Okay, let us do the calculation. So note that velocity of image along y-axis, right? Image with respect to mirror along y-axis does not change. It remains same as object with respect to mirror along y-axis, right? This is what formula we have seen, correct? Along y-axis, relative velocity does not change. So now suppose I want to calculate relative velocity. So this is how we have already got this object along, this is 4, so this is also 4, correct? So velocity of image uh, with respect to mirror along y-axis is 4, correct? Right. Velocity of image along y-axis is 4, right? Okay. This diagram we will draw afterward. First we'll see what is the value, afterwards value will put it. Value will put afterwards. But we know we are drawing relative velocity first. Okay. Actual velocity we will draw afterwards. Okay. One is the actual velocity. This is the actual velocity. Let us keep actual velocity. Relative velocity first we are drawing. Okay. So let me draw relative velocity. So this is velocity of image with respect to mirror along y, and this is velocity of image with respect to mirror along x, and this is the actual velocity of image. So velocity of image along x and velocity of image along y, just like this diagram here. You see, this is velocity of object along x and y, this is velocity of image along, and that also we need to calculate, and this also we need to calculate. We need to calculate both, right? Image velocity and relative velocity with mirror, both we need to calculate in the question, correct? So first, what we are calculating is this diagram. We are calculating relative. Relative remains same, 4. Now, if you want, you can write this also as velocity of image minus velocity of mirror. This is along the y component, correct? Y. And we know velocity of mirror along y-axis, that is 3. So velocity of image along y-axis minus this is 3 is equal to 4. So from here we can calculate. Here we can calculate velocity of image along y-axis is 4 plus 3, 7. Okay. Okay. So from here what do we understand? We understand simply one thing, that this component which is 7 does not change. That's what I told. Parallel component you don't have to worry. Same thing you can write. Okay. So whether it is relative or whether it is actual, that will be same. Okay, that will be same. So this is coming as, this has come as 4. So if you are taking relative, here relative diagram 4 4. Actual diagram also 7 7. Correct. Are you understanding? But when we calculate along this is going to change. Okay, so let us now apply formula for this. Okay, let us apply formula. So relative velocity of image with respect to mirror along x-axis is minus, remember, minus velocity of object with respect to mirror along x-axis. Okay, and now we will apply the formula. So first of all, we already know object with respect to mirror along x-axis. This one was minus 6, right? Minus 6 it is. So minus of minus 6 we have to keep. That becomes plus 6. Okay. So in the relative velocity diagram, which here we have written 4 here, and here we need to write plus 6. So this will become plus 6. This is relative velocity. Okay. So relative velocity we got it, but we want velocity of image. So let us first, but also note that no, we need to calculate velocity of image with respect to object. That we'll do afterwards. Okay, we'll do after. This is velocity of image with respect to mirror only. 6 along x-axis, 4 along y-axis. Okay, but what they are asking in the question, they are asking velocity of image with respect to object, not with respect to mirror. That we need to calculate, and that we can calculate only when we know velocity of image. So that's why first we need to calculate velocity of image. Okay, right. So we got this one. Okay, now let us calculate velocity of image. So velocity of image with respect to mirror is velocity of image minus velocity of mirror. These are the x component. So calculate velocity of image along x minus mirror. Mirror along x axis is what? Mirror along x axis is 2. 2, right? That is 2. So 2 here you keep it, and this has become 6. So from here velocity of image along x axis becomes 6 plus 2, 8. Right? We got this. So we got velocity of image x component, velocity of image y component. Clear? So now we got, finally we can say we got the answer. We got what? We got image. Image is moving along x axis with a speed of 8 meter per second and along y axis with a speed of 7 meter per second. This is the actual velocity of image. Okay, this is actual velocity of image. You can calculate actual velocity vector may come like this direction. Okay, this is velocity of image. You can calculate. If you want velocity of image to write as vector, you write 8 I cap plus 7 j cap. This is the answer, velocity of image. Clear? Okay, any doubt in this? No, no, no. This is actual velocity. This is actual velocity. Okay, velocity of image with respect to object. Now we will calculate. Now we will calculate. So velocity of image with respect to object. Now directly calculate velocity of image minus velocity of object. Write as vector. So this we have already calculated, 8 I cap plus 7 j cap minus object velocity is already given in the question. Substitute it. So this is minus 4 I cap plus 7 j cap. Substitute it. Minus 4 I cap plus 7 j cap. Minus 4 I cap plus 7. Substitute it. Substitute and do the calculation. That's all. You get it, right? So 8 minus minus plus 8 plus 4 12 I cap and 7 minus 7 0. That's all. This is the answer. Velocity of image with respect to object. Now this method which I am telling you, it can never be wrong because you are using the exact formulas. Okay, you are breaking into component and then using the formulas. Another thing is shortcut. If you want quickly within 1 minute, then that also I will tell you, but that you have to take care of while doing calculations. Okay, for that you should know that in same direction we subtract, in opposite direction we add, in parallel direction no changes. Like that we can fastly do calculations. Okay, so let's do the fast calculation. We have got the answer. This is image velocity, this is image with respect to object. Okay, but let us do fast calculation. Fast calculation we will do here. I will draw this diagram again and fastly we'll do. So if you see this mirror, mirror has velocities along this direction 2 meter per second, along this direction 3 meter per second. Object has velocity in this direction 4 meter per second, in this direction 7 meter per second, right? Okay, so what you need to think is the image that will have image velocity along this direction no change, that will remain 7 only. 7 meter per second it will remain, there won't be any changes. Okay, and now if you see here, if this is going like this way 4, right, with respect to mirror how much it will be? With respect to mirror it will be, because the mirror is going opposite, so with respect to mirror if you see this will be 6 this way. Okay, this way it must be 6. So relative to mirror it must go 6 meter per second relative to mirror. So the image relative in this direction only, relative in this direction must also be 6. Okay, relative must be 6 in that direction, opposite. Now I want actual velocity in this. Remember this is relative velocity, right? But I want actual velocity of image in this direction. So now you can apply this, because this velocity, this 6 is what? This 6 is the velocity, relative velocity. So relative velocity means what? It is velocity of image minus velocity of mirror. This is only along x-axis. Okay, and you know velocity of mirror along x-axis. Along x-axis is 2. So 6 is equal to velocity of image along x-axis minus 2. That's why velocity of image along x-axis becomes 6 plus 2, that is 8. That's what you can write as 8 meter per second. Okay. So now you see very less calculation is there. So directly now you can calculate. Now you can calculate that this velocity is 7, this velocity is 8. Here also you see this velocity you have got 7 and this is given already as 4. Now tell me. Now see, now you compare image and object. Okay, now you compare image and object. So you are studying this image and you are studying this object. Now study image with respect to object. So image is going along y-axis 7, object is also going 7, same direction, so relative velocity 0, right? Subtract 7 minus 7, 0. So relative velocity, if you take image with respect to object, image with respect to object, so in this direction, image with respect to object is 0. Okay, along y-axis it is 0. But now you see, this is 8 and that is 4. 8 plus 4, 8 plus 4, 12. Correct? That's what, plus 12, that's what we got. Okay, clear. Now if you have any question on this, you can ask. Done. So that's all. So any type of questions on this can be solved using this way. Even if this question is a quite a complex question also, you can solve it. Okay. One question I will give. Recently one JEE advanced question was there. One person was asking, but tell I will solve within few seconds this question. Okay, the question was that this is x-axis here and this is y-axis and z-axis is the vertical line. Okay, this is xy plane, like this xy is the horizontal plane, z-axis is perpendicular. Okay, so this xy plane represent mirror. They were saying that the mirror is parallel, not exactly xy, but mirror is parallel to this xy plane. Actual xy may be somewhere else. Okay, but they are saying that this mirror, this is mirror is parallel to xy plane. They are saying mirror is parallel to xy plane. So let me consider one xyz coordinate system. This coordinate system may not be the origin, but actual may be like this way. Xyz origin may be like this, but this xy parallel means what? Parallel means this xy plane is parallel to this plane, right? That's what it is. These two planes are parallel, correct? Okay, so parallel means what? Suppose if I consider z-axis, so z-axis is perpendicular to xy plane. So here also perpendicular will be along z-axis only, correct? Perpendicular will be along z-axis. So perpendicular, if I draw here, which is z-axis, here also perpendicular will be along z-axis only. Okay, so they had given a question. What is the question? They had given a question that this mirror is moving with some velocity. Okay, let us say this is the velocity of mirror, and mirror velocity is, let us say, 2 I cap plus 3 j cap minus 4 k cap. Okay, this is the velocity of mirror, and object is moving somewhere with some velocity. Object velocity is given. It is going, velocity of object is uh, 4 I cap minus 10 j cap plus 3 k cap. Like this it is given. The question was, find the image velocity. Find velocity of image. This is the question. Okay, I have taken a similar question, not the exact question, but similar question. How to calculate this? Okay, so now let us try to understand how to calculate it. Okay, I want to do this calculation. So first of all, note that velocity of object has all the three component x, y, z, right? And velocity of mirror is also having all the three components x, y, z. But what we need to think is which component will change. Can you tell me which component of the velocity of image will change? X component, y component, or z component? Think. Just now we discussed here this question. Now tell me which component was changing. You see this object velocity was 7, even image also comes 7. So which component changes? Which component changes? X component, because it is perpendicular. Perpendicular. So only perpendicular component will change. That is the key idea. The key idea is that only perpendicular component will change. So coming back to this question, perpendicular component is what? Z, Z come. Okay. Only k cap will change. So the answer of this will be 4I minus tan j, but we don't know what is k. K must be different. K component will be different. Okay. What is k? That is what you need to calculate. Okay. What is k? That is what. That means only perpendicular direction we have to do calculation. So let us just calculate the perpendicular direction. So this is the velocity of object. This is the velocity of mirror. Okay, so let us write now. Only perpendicular component means z direction will write. So velocity of object in z direction, z component. What is the z component? That is plus 3, 3 only. Okay, 3. Just let us write just only component. Let us write. Okay, so velocity of object along z direction is plus 3. Velocity of mirror along z direction is minus 4. Correct. Just now let us apply the formula. Velocity of image with respect to mirror is equal to minus velocity of object with respect to mirror. This is the z component calculation. Okay. Hmm. Do that. Hmm. So this is velocity of image minus velocity of mirror, velocity of object minus velocity of mirror. Correct. But there is a minus sign here, so minus minus will become plus. Correct. So we want velocity of, these are all z component calculation. Z component, right? So calculate this. Velocity of image we want. Velocity of image with z will become velocity of minus velocity of object with respect to plus 2 times of velocity of mirror with z over, that's what it is. Object along z axis is this 3, right? So minus of 3 plus 2 times this is minus 4. So how much it becomes? So minus 8 and 10, 11, minus 11 over, got it? You got na image. So that is minus 11. So that is what the answer will come. So here we need to put minus 11, and that is k cap. That's all. That's the answer. Got it? That's the answer. So in just 1 second we got the answer. Not much calculation is there. But now if they ask what is velocity of image with respect to object, so then you do velocity of image minus velocity of object, right? So these terms are same only, na? These terms and these terms are same. They will get cancelled. Only thing you have to do z component. So image you have got as minus 11 k cap, and object you have got plus 3, so that means minus of 3 k cap. So you got this is minus 14 k cap. That's the answer. Clear? It becomes, so the idea is once you get that, then you can. But the problem is that now see what is the problem. Here they have given the mirror along xy plane, along xy plane. So you can easily decide what is the perpendicular direction, which is z axis, right? Z axis. So along z axis only I have to do calculation, right? Okay, but the problem, if it is more complex, they will give the equation of the plane. They will give the equation of the plane. Okay, and if they give the equation of the plane of the mirror, which is neither x-axis xy nor yz nor xz, neither parallel to any of them, some other plane they give, that is where complex calculation will happen. Okay, some complex calculation will happen. That means you need to first of all find the direction perpendicular to that. Okay, so that derivation will be quite complex, and you should know first of all how to write the equation of a plane in 3 dimensions. Do you have idea? Plane equation in 3 dimensions. No idea. Okay, I'll tell you this you should know. It's a linear equation. Just like in a two-dimension plane, y equal to mx plus c. That's a linear equation represent a line, right? Linear equation represent a line. Similarly, in three dimension, in 3D, in three dimension, a linear equation like ax plus by plus cz is equal to something like d. Okay, this represent a this represent a this represents a plane. This represents a plane. Okay. So now if they give the equation of a plane like this, okay, I just give you simple like a mirror is kept along a plane along a plane. The equation of the plane is given, let us say 2x plus 3y plus 4z is equal to, let us say 0. Okay, that's the equation. So mirror, this is the equation of the mirror. Okay, now if they give the mirror, they have given mirror is this plane, and they give the object velocity. Object velocity they give, let us say I cap plus j cap plus k cap, like this they give. Then they ask find image velocity. Find image velocity, and also they may give the mirror is also moving. The mirror is moving with a velocity, let us say 2I cap minus j cap plus 2k cap, like this mirror velocity is also given. Then they ask this question, then 99.99% will not be able to solve this. Okay, because they have never thought it in their life. They are going, people are going for national exam, but they never think, right? Why they not think? Hmm? Can you hear me? Are you, noise is there? Hmm. Okay. Are you able to hear me clearly? Okay. So how to solve this type of questions? People need to think about it. Not that whatever is given in the book only that I will think. That kind of mentality will not be helpful. They need to think if the question changes, if things changes, if they give more information, if they give less information, how should I do calculation? This is the thing. They will give the equation of the mirror, and they will give object velocity, mirror velocity, how to calculate. So the first thing is that we need to find out what is the direction which is perpendicular to the mirror. Perpendicular to the mirror, right? Perpendicular to mirror, I need to calculate. How do I calculate perpendicular? How do I calculate perpendicular direction? So for this, I give you one simple method that is called, see any surface, I will tell you, any surface, any surface is represented by phi. Phi is a function of x, y, z, is in terms of, let us say anything. For example, if it is a plane, here plane can be like ax plus by plus cz plus d. This type of equation of plane phi is equal to 0. Okay, like this. So this type of means this is phi, this is a function. This represent a surface. This function represent a surface. Okay. So now, for example, if you take this plane, write this plane which is given. So this phi can be written as 2x plus 3y plus 4z. This is function, and we calculate this del del of phi. Del vector, or it is also known as grad vector, gradient. Okay, gradient, gradient of phi. Gradient of phi is called, I think this is called reverse, reverse way. This vector, del of phi. So when you calculate del, I think you know this operator. What is del vector? That del vector is called dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. You have seen this function, this operator in energy, work energy chapter. You have seen that, right? Work energy. In electrostatics it was there. In electrostatics. Okay. Ah. Okay, so let us calculate this del of phi means. So here del means partial differentiation. So let us do partial differentiation first. Okay. So that means you have to do dou phi by dou x I cap plus dou phi by dou y j cap, dou phi by dou y j cap plus dou phi by dou z k cap. Let us do this calculation. Okay. So dou phi means what? This is phi. Now we need to only differentiate with x. So y and z are treated as constant. I think you know about partial differentiation, right? You have idea of partial differentiation. So here yz you have to take as constant. So only 2x with x. 2x with x will give 2 only. Okay. Similarly, with respect to y, it will give only 3. Okay. And with respect to z, it will give 4 only. Like this. So once you got this vector, you got this is a vector along the normal direction. Okay, along a normal direction. So now you can calculate. Now you can calculate a unit normal vector. Unit normal vector, which is, let us say, n cap. A unit vector, how do you calculate? You know, a vector divided by its magnitude, right? Vector divided by magnitude is called unit vector. Okay, so this vector divided by magnitude you do. So 2 I cap plus 3j cap plus 4k cap divided by magnitude of vector 2 square plus 3 square plus 4 square. Calculate this. So you can calculate this normal part. So 2I plus 3j plus 4k divided by root under how much? 16 plus 25 for 29. Okay, this is a unit vector along this perpendicular direction. Okay, so once you get a vector along this direction, so suppose this is a surface plane and you got this normal vector in this direction. Okay, normal vector you got. Okay, so once you have got normal, and suppose the object is moving like this way, for example, this is the object velocity. Object is moving, and that also you can take as the relative component if you calculate relative, otherwise you take object velocity. So object velocity we can resolve in this direction. One object velocity in this direction we can resolve this direction. This is object velocity which is parallel to mirror, and this is object velocity which is perpendicular to mirror, right? Correct. We can calculate this. So we can calculate object into two. One is parallel to mirror, another is perpendicular to mirror. So if you are calculating the image, let us say you are calculating the image. So image velocity in this direction parallel will not change. Parallel will not change, but in the perpendicular direction only it will change. That means this will be the image velocity perpendicular direction. So this is image velocity in perpendicular, this is object velocity in perpendicular direction, and this is, let me write, this is object parallel, object perpendicular, that will be better. Okay, so this is object in the parallel direction and this is object in the perpendicular direction. Object in the perpendicular means perpendicular to mirror. Okay, and this is velocity of image, this is velocity of image, image parallel to mirror, and this is velocity of image, velocity of image perpendicular to mirror. Correct. So what will change is velocity of image parallel will remain same as object parallel. Clear? This we know already. This direction it doesn't change. Correct. If you want, you can write them as vectorly. Vector you can write. If you want, you write them as vector like this. Write them as vector. Now, if I want to write velocity of image, which is perpendicular component, that is going to be minus velocity of object into perpendicular component, right? This is what happens. That's what happens. So what you need to do is, we need to calculate both the components of object we need to calculate, and the parallel component of image will not change, but perpendicular we have to put minus. That's all. Now the thing is that, how do you calculate parallel and perpendicular? That is the question. How do we calculate parallel and perpendicular? Correct. How do we calculate object? So you know how to resolve a factor along this direction, along this direction. Do you know now? Resolution of vectors, you know, correct? So if somehow or the other, if you can calculate what is this direction, means angle, okay, or let us call this as relative velocity. You may say that this is relative velocity also, because the image may also move in here, means mirror may also move in this somewhere direction. This is object with respect to mirror, let us write, okay, so that confusion should not happen, because you are making the mirror at rest, okay. Let us keep this as relative velocity. Relative velocity, let us keep. So this is velocity of image with respect to mirror, and this is in parallel direction. Okay, this is velocity of image with respect to mirror. It is in perpendicular direction, parallel and perpendicular. Similarly here, this is velocity of object with respect to mirror in parallel direction. This is velocity of object with respect to mirror in perpendicular direction. Okay. So when you are writing this, this is the image with respect to, let us write image with respect to, also object with respect to. Okay, relative velocity, let us write this. So velocity of object, sorry, velocity of image with respect to mirror in parallel direction. Velocity of object with respect to mirror in parallel direction. Here this is velocity of image with respect to mirror in perpendicular direction. Velocity of object with respect to mirror in perpendicular direction. That's the actual formula. Now this calculation of this will depend on how can we do the dot products, because this is dot product calculation. Okay. So for this you should know how to calculate the parallel component and perpendicular component. Okay. So that I will give you formula before you go further. So suppose that there is a vector A vector. Okay, there is a vector A vector and there is a vector B vector. You know both the vectors. Okay, you know both vectors A vectors and B vector, and I want to calculate the component of A vector along this vector. That means you can say this is a parallel, and I want to calculate A which is perpendicular. Okay, so let me tell you directly how to calculate a parallel vector. A parallel vector will be calculated as component of A vector along B, that is A vector dot B cap, and when you want to calculate a perpendicular, you can write A vector minus a parallel vector. Simple calculation is this way. So, questions are not very complicated, but you need to know the vector formula. Suppose A vector is there and B vector is there, you want to write the vector component along B, you will use this formula. And you want to write vector component of A in this direction, you will use this formula. Okay, that's the vector. Then using this formula, this problem can be solved. Although this type of questions does not come in, even in JEE main or you know in a NEET, but if they decide to keep the question tough, then they can give. Like this time they have decided to keep paper tough, then they will keep it, and then people will suffer like that, right? Hmm. We don't know. The thing is that in NTA they are making so many modifications. Now they are saying that they will keep computer based, CBT exam will be there. First of all, they have decided that CBT mode will be there. And CBT mode is anyway going to be difficult for people, those who are not habituated for that. Right? Because CBT means the computer screen they have to look and they have to put it. It is like JEE main exam. So People who are habituated of solving no, on papers, they will face some difficulty there. Okay, on the computer screen, they have not practiced. That difficulty will be there. Another way is that they will not, in that case, they will not keep very difficult paper. They will keep up to JEE main level only. So if they are keeping CBT mode means it will be JEE main, and in JEE main also sometimes difficult questions comes in regularly. So at least 5 6 questions. Hmm. Moderate they can keep. Easy to moderate level they will keep, not difficult level. They won't keep very difficult level. Okay, they will not keep very difficult. Easy to moderate level you can expect. Okay. So that's why you practice now writing on computer screen exam. That's why I'm creating regularly question paper test papers. So you can write. You will have habit of writing papers. Yeah, yeah. We can wind up. Okay. That's all. You have any doubt in this? No. Yeah, yeah. I understand. Hmm. Okay, then we'll see next tomorrow. We have class, right? We'll see tomorrow. Okay. So let's wind up this session. Hmm. Hmm. Apollo. Hmm. Yeah, yeah, yes. Yes. So mm, that's right. It's,